So as I promised you yesterday, I'm done lecturing you on investment and savings and financial stuff. Does anybody have any questions off of the homework from Monday and Tuesday? Okay, well, if anything comes up, just let me know. I'd be happy to go over it more with you if you need. So today we are wrapping up Unit 2, which of course means tomorrow, Thursday, February 11th, Unit 2 test. And we have a couple of items that we have to finish up here to be ready for that. We have talked briefly about converting between fractions and decimals. I want to convert a decimal to an exact fraction. The keyword there is an exact fraction. If I have something like 0.0875, convert that into an exact fraction. I'm going to read it off as it is written, as it would be pronounced, and then put the appropriate denominator underneath it. That would be read as 875 tenths, hundredths, thousandths, 10,000ths. Now remember, we had mentioned a way to double check is the number of decimal places, 1, 2, 3, 4 decimal places, should be the number of zeros, 1, 2, 3, 4, in the denominator of that fraction after we make that initial conversion. Now, of course, this fraction can be reduced. Both 875 and 10,000 can be reduced. I will start by 25. 875 divided by 25 is 35. And 10,000 divided by 25 is 400. And both of those can still be divided by 5. 35 divided by 5 is 7. And 400 divided by 5 is 80. So as an exact fraction, that is 7/80ths. That's a process we've seen before. Different process. The wording is very similar. Convert to a fraction to the nearest often when we're dealing with measurements, we might do a calculation and we get the result is that we need something 0.0875 inches size. But when you're dealing with mechanical things and hardware and stuff, they don't necessarily come in every possible decimal dimension. They come in standard sizes, halves, quarters, eighths, sixteenths, whatever. Here, we're assuming that whatever it is we're trying to dimension only comes down to the nearest 16th. The process, now we just did the same decimal up here to the exact fraction. The process of converting that decimal to a fraction to the nearest 16th is very, very different. From the very beginning, it's a different process. Take our decimal, 0.0875. And we are going to make it a fraction, but we're not going to make it a fraction based on the decimal place. Up here, this fraction was created based on the decimal place, original decimal. Here, we're going to convert that into a fraction by simply putting it over 1. Notice the decimal is still in there. The decimal has not been removed. Now, currently, we have a fraction with a denominator of 1. We want a fraction with a denominator of 16. Turn that into a 16. Well, to change the denominator of a fraction, we multiply. 1 times 16 gives us 16. We would now have 16ths as our denominator. But recall, if we multiply the bottom of a fraction, we must multiply the top of a fraction, the numerator, by the same amount. Take 0.0875 times 16, we get 1.4. So that converts to 1.4 sixteenths. Now we don't want 1.4 sixteenths. This says we want it to the nearest 16th. So 1.4 is between 1/16 and 2/16. So it's going to be one of those two. 1.4, well, the 4 is less than 5, so it's less than halfway to the next one, which means we're going to go to the smaller one, the 1/16. We're converted to the nearest 16th. That is just a 16th of an inch. So let's look at the difference between those two processes again with different numbers. Let's convert to an exact fraction. Left side of the screen. Right side of the screen, we're going to convert to fraction to the nearest. We'll name what fraction we're going to the nearest when we get to each example here. So let's do 0.645. Converting to an exact fraction, that is 645 over, hence hundredths, thousandths, or 1,000. And we can reduce that. Both of those numbers divide by 5. 645 divided by 5 is what? 129 over 1,000 divided by 5 is 200. I believe that is actually it. Nothing more we can reduce that by. So it's 0.645 is 129 over 200. Let's over here take 0.645, nearest. Well, we did to the nearest 16th last time. Let's go to the nearest 32nd of an inch this time. So just like we did up above, we're going to take the 0.645, and instead of taking out the decimal point and putting in the denominator according to the place value, we're going to leave the decimal point in it and just put it over 1. Now we have a denominator of 1, and we want a denominator of 32. So to do that, we multiply the 1 by 32, giving us a denominator of 32. Must also multiply the numerator, the top of that fraction, by 32. So 0.645. 32 is 20.64. So 20.64, that is between 20 30-seconds and 21 30-seconds. Since that is 20.6, we go to the larger one. That is 21 30-seconds of an inch. Notice the drastic difference in our results. This is 129 200ths. This is 21 30-seconds. If I divide those back out, of course, 129 over 200 is going to give us right back to the 0.645. 21 divided by 32 will be slightly different, but it's pretty darn close. In 30-seconds of an inch, that's as close as we can come to the 0.6. One more example. So again, exact fraction on the left. Converting to an exact fraction with starting with 4.294. Convert that to an exact fraction. First, we have the whole number in front of the decimal point. As we mentioned, we're going to take that off, and we're not going to do anything with it. 0.294, well, that's 294 thousandths. Tenths, hundredths, thousandths. 3 decimal places, 3 zeros in our denominator. Both of those numbers can be reduced by 2. So I'm going to divide by 2. 294 divided by 2 is 147. 1,000 divided by 2 is 500. And I don't think that can be reduced by anything. 147 can actually be divided by 3. That doesn't help us anywhere here. So that's as far as we're going to reduce it. So it's 4 and 147 500ths. That is as an exact fraction. Let's take the 4.294 inches to the nearest. Well, let's say we're going to the nearest 64th of an inch. Well, the one part here that is similar to the exact fraction is the whole number is just going to get pulled off, or isn't going to change. But the way we handle the fraction is totally, or the decimal portion is totally different. So there's 0.294 there. I put it over 1 to make it a fraction. Notice the decimal point is still there. I want this to have a denominator of 64, so I'm going to multiply my 1 by 64 to make it 64. I have to multiply the numerator by the same amount. 0.294 times 64 is 18.816. Now, once again, this is between two numbers. 18.8 is between 18 and 1964. And we have to pick which one it's closest to. Well, it's 18.8, which means it's closer to the larger one, the 1964s. This is 4 and 1964. Again, please note the drastic difference between those. On the test coming up tomorrow, there are a few problems where we have to do this. This process over here, going to the nearest 64th or 32nd, is not in your textbook. So make sure you have that, you've looked at that process and you're comfortable with it. Okay, so next, last topic we have here is our last set of inverse pairs. In math, all operations come in pairs, and they're called inverse pairs. We have addition and subtraction. Add and subtract. If I pick a number, let's say I'm going to start with 12. And I pick another number, let's add 7 to it. So we're going to add 7. 12 plus 7 is 19. If I want to get back to the 12, I'm going to take my 19 and I'm going to do the opposite. Opposite of adding 7 is subtracting 7. That gets me back to 12. If I add a number and then subtract the same number, I get right back to where I started. Similarly, if I started with the 12 and subtracted 7, 12 minus 7 would give me 5. If I want to get from that 5 back to the 12, the opposite of subtracting 7 would be adding 7. That gets me back to the 12. So if I subtract first and then add the same number, I still get right back to where I started. We have multiplication and division. Multiply and divide, I have a similar setup. Let's start with 12 again. This time we're going to multiply by 4. 12 times 4, 48. If I want to get from that 48 back to the 12, I would divide by 4. 48 divided by 4 is 12. Multiplying by a number and then dividing by that same number gets us right back to where we started. They reverse each other, cancel each other out. If I started with the 12 and divided by the 4, 12 divided by 4 is 3. If I want to start with that 3 and get back to the 12, I'm going to multiply by 4. 3 times 4 is 12. So here again, if we divide first and then multiply by the same number, we get right back to where we started. They cancel each other out. Well, our third set of inverse pairs is powers and roots. And we've looked at these briefly when we did integers dealing with the negatives, so we don't need to spend a lot of time on them. But we know that if I have something like 5 to the power of 6, that means we have 6 5s multiplied together. 5 times 5 times 5 times 5 times 5 times 5 is 15,605. If I want to reverse this, now recall that these powers have two parts to them. The 5 is referred to as the base. That's the number being acted upon. The 6 is actually referred to as the power. If I want to reverse that, we use a corresponding root. Corresponding root has an index that is equivalent to our power. So this symbol here that most of us call the square root symbol, it's actually called the radical symbol. And it is most often used for square roots, but it can be used for other roots as well. It has an index. Square root, there's nothing written there when it's a square root. That's just assumed to be 2. But for other roots, you can put other numbers in there. This is a power of 6. This would be an index of 6 in our root. That 6, as mentioned, is called an index. And what it indicates what power is being inverted, basically. Undone, if you want to. So this is saying the power of 6 is being inverted. So if that is the 6th root of 15,625, that 16,625 is once again the base, or sometimes called the object of the root. That is the number being acted upon again. Well, the 6th root reverses the 6th power. So if 5 to the power of 6 is 15,625, the 6th root of 15,625 is 5. They reverse each other. On your calculators, you all know how to calculate powers. We've gone over it. You either have that caret key that looks like that, or you might have an x to the y or y to the x key. Some of them might even have like an x to a box or a box to a box. All of those keys act the same way. If I want to do 5 power of 6, I enter the 5, I press whichever key it is, and I enter the 6, then I hit equals or enter. 15,605. My calculator here is a little bit different because I have to go through menus. 5, then I use the math menu. Oops, sorry, I have the caret key for the power. I'm thinking the roots. I hit 5, I hit the caret key, and I hit the 15,625, just like you would on your calculator. However, to reverse it, excuse me, we know the answer here, but let's go through the process of reversing it. 6th root of 15,625. We know it has to be 5. To make our calculator do it, most of you, it will be a second function or a shift function. Some calculators have a shift key, others have a second key. And the bigger roots, the square root usually has its own key on the calculator, but the other roots are a second function, which means generally whichever key you have, let's say you have the caret key, it's going to be right above it. It'll be x root like that, or sometimes n root. So to do a root other than a square root, you have to find that key. And the way you enter it is you would enter the root first. This is a sixth root, so I do 6. Then you would have to press the second key or the shift key. Then you press whatever key it is that has that x root above it. Then you would enter the 15,625. On my calculator, it's a little different. I do still enter the 6 first, but I go to the math menu and select the x root. Enter the 15,625. And I do get the 5. In this class, we're not going to do too many higher roots other than square roots. Most of your calculators do have a dedicated key for square roots. If I just want to do a square root of 676, pick that because it's one that you probably don't have memorized. Most of your calculators have an x squared key like this. Because the power of 2 or squaring something comes up often enough, rather than having to do your power key and then 2, they put that squared key on there so it saves you a key string. Most calculators, the Texas Instruments at least, square root then is the second function above that key. If you have an older calculator, a one-line display calculator, it has its own key. Square root has its own key just above the number pad, just like that. Both of those keys, well, depending on which key you have, it actually works slightly different. If you have this key here, what you'll do is you'll hit second. So that gets you to the square root. Then you press the key with the square root above it. Then you would type in the 676. That's how it works on my calculator. Second, square root, 676, and I hit enter. I get my result of 26. Most calculators work that way. You have to select the square root symbol, then enter the number. If you have a dedicated key like this, most calculators that have a key like that, however, work backwards. You would have to enter the 676 first, and then press the square root of x key. And you don't have to hit equals. Once you press the square root of x key, it automatically calculates the square root. It gives you 26. You don't have to hit the equals key there. The enter key. Okay, so with that does, I'm a little short. I'm about 5 minutes early here today. No problem. Well, actually, about 8 minutes earlier today. That is all we have for Unit 2. Last bit of homework out of the book is page 93. The odds. Dealing with calculations with powers and roots. Again, not in the homework, but that converting to a fraction to the nearest set denominator is a big thing. There are 4 problems on the test about it. Does anybody have any questions here?
No.
So tomorrow for the test, just like the last test 2 weeks ago, I will log into class to see if anybody has any questions, but there won't be any lecture or presentation tomorrow. It'll just be about completing the test. So as long as you have the test completed at some point tomorrow, you don't have to log into class. I would recommend that you look at the test before class time, just so you know if you have questions. So if you do have questions, you can log in right away at the beginning of class. If nobody logs in the first 15 minutes or so, I will most likely log out and call it a day. But I will be there for the first portion of the class just in case somebody does have questions. So I do recommend that if you can, you start the test either tonight or tomorrow morning so that you are ready to ask me questions, if you have them at the beginning of class tomorrow. Otherwise, like I said, if you do the test and you're good with it, there's no need to log in for tomorrow's class. With that, I will shut up and give you guys time to do your homework. We've got about 23 minutes left.